Hi, this is Maggie. In this video, we'll look at how string data is compared. Strings are stored as a series of individual characters. Each character has an underlying numeric representation in the Unicode encoding. Because characters are represented by numbers, they are ordered by numeric representation. This page is on the unicode.org site, and it is the basic Latin character set. If I pop quickly back to the list of Unicode tables, you can see that there are an enormous number of characters that are represented in Unicode. We'll just focus on basic Latin here because the principles are the same. Uppercase A, you can see, is represented by the number 41. That's hexadecimal 41, which happens to be decimal 65, but it doesn't matter for this discussion. The point is that there is an order to the characters. Uppercase B immediately follows uppercase A with the number 42. Uppercase C is 43, and so on. The lowercase letters are also in order, but they start with hex 61, so they're ordered separately from the uppercase characters. Knowing this, you can hopefully see how individual characters are compared. Uppercase A is less than uppercase B, which is less than uppercase C, etc. Uppercase A is also less than lowercase a, because lowercase a is represented with a higher numeric value. Strings are compared lexicographically, which means following a set of rules for how sequences of characters are compared. The rules are very similar to alphabetic order. Here's how it works. Let's assume we're comparing two strings, and let's work with a few examples. Here I am showing the strings C++ and C++, alpha and beta, and Rob and Robert. We are going to compare each set of two. The algorithm for comparing first looks at the first character of each string being compared. If one of the characters is larger, then that string is larger. For C++ and C++, both strings begin with an uppercase C, so that comparison is not yet over. For alpha and beta, the B in beta is larger than the A in alpha, and so beta is the larger string. That comparison is over. With Rob and Robert, the first character for each is uppercase R, so neither string is larger yet. We have to keep looking. For the two comparisons that are ongoing, we then proceed to the next character in the string and compare again. Again, for C++ and C++, comparing the first plus, they are the same. For Rob and Robert, comparing the lowercase o, they are the same. We must move on to the next character. For C++ and C++, comparing the second plus, they are the same, and both strings are out of letters, so those strings are the same. For Rob and Robert, comparing the B, they are the same, but one string, Rob, has run out of letters. When this happens, when one string runs out of letters, but the strings were exactly the same to that point, then the longer string is larger. Robert, therefore, is larger than Rob. We can test out these comparisons in the idle console just to confirm that this is the algorithm Python is using. I will type in quotes Robert greater than, and then in quotes Rob, and I expect that to evaluate to true, and it does. I will type C++, again in quotes, greater than C++, and of course, we expect that to be false because they are the same. Python evaluates the expression to false. And finally, I will type beta, in quotes, greater than alpha, in quotes, and Python evaluates that expression to true. I recommend that to practice with this, you try comparing strings with embedded non-alphabetic characters and with a mix of uppercase and lowercase letters, predict the results, and test your prediction in the console. Try comparing numbers, numbers with more than one digit, like 109 greater than 9. When you can predict with perfect accuracy, you're ready to move on.